Much of our infrastructure is made of metals to ensure structural stability. However, over time, these metals break down and rust due to a phenomenon known as corrosion. Corrosion is a problem that does not get a great deal of media attention. According to a landmark study by the National Association of Corrosion Engineers, in 2016, corrosion alone will directly and indirectly cost the U.S. economy over $1.1 trillion. The cost of corrosion is at 6.2% of the United States GDP, the highest percentage it's ever been. It is estimated that 1/3 of this cost could be prevented by applying existing corrosion control technologies. Did you know every decade it costs roughly $500 million to paint the Brooklyn Bridge in New York? These types of costs keep our transportation systems running safely. Without repainting, the bridge would simply decay and corrode over time, leading to safety and economic issues. So what is corrosion, and why should we be concerned? Corrosion is the result of a slow breakdown of metals when they chemically react with their environment. Technically speaking, it is the result of an electrochemical process where a metal willingly gives up electrons to become more stable. An electrolyte, an exposed metal surface, and an electron acceptor are all needed to produce corrosion. Metals containing iron reacting with oxygen and water create a new compound called iron oxide, otherwise known as rust. Stainless steel resists corrosion over long periods of time, but if pitting occurs, the metal will become weak and corrosion will spread. Filiform corrosion is a type of corrosion that takes place underneath painted or plated surfaces where moisture infiltrates the coating and spreads. This type of corrosion usually begins at the microscopic level inside defects of a coating. Preventing filiform corrosion is as easy as avoiding quick-dry paints and inspecting for bubbles and other defects in the coating. There are many types of corrosion, and all of these forms are similar in that the metals are unstable and they chemically react with their environment, resulting in a slow and gradual breakdown. Galvanizing is a protective process that coats the underlying metal with another more active metal, such as zinc, which helps inhibit corrosion underneath. The coating of a more active metal on top of an underlying metal is known as anodic protection. An interesting way to protect against corrosion is through the use of cathodic protection, which protects the metal from corrosion by producing a continuous negative electrical charge and passing it through the metal. This helps to stabilize the metal. Usually the source of the negative charge is an outside direct current supply. This form of protection is typically used in pipelines and underground fuel tanks. Besides protective coatings, engineers can design to more efficiently handle corrosion. For example, draining water at the bottom of a car door can help prevent corrosion in future models. Also, by over-designing, engineers may add extra metal to a platform to compensate for a corrosive environment. This is known as corrosion allowances.